assign some of you to watch the video, right, about the centripetal force. I hope you already do so if you missed the first meeting. So today we're going to learn the continuation of that. So we start with this. See the whiteboard on your screen already?
Yes, sir.
Yeah, so we're going to discuss about the gravitational field. Gravitational field is radial. If you are being asked about what is the definition of radial, radial is always perpendicular to the surface of the planet. You see the whiteboard on your screen, right? Or haven't?
It is, sir.
Yeah.
I've already.
Okay, so if he asks you what is the definition of radial, radial means the lines, right, always perpendicular to the surface of the object. I'll give you a sketch. So let's say this is Earth, right? So if you're asked to draw the gravitational field lines, the gravitational field lines, right, the drawing will be like this. So it's always perpendicular to the surface of the Earth. And then if you extend the lines, right, all of the lines will meet at the center of the planet. That's the definition of radial. Next, for Newton's law of gravitational, you have to read carefully. For any two-pointed mass. So pointed mass, right? Last time I explained to the side 4 already. It means like this, right? Let's say we stay on Earth, right? And then if we compare our distance to the sun, the distance is very far apart. So both of the objects, right, if you look at each other, we appear as a small point. So only for pointed mass, right, you can apply this rule. You understand until here? So for a pointed mass, the force is directly proportional to the product of both masses, right? But inversely proportional to the square of the separation. So let's say you have two objects, first and second. So the gravitational force between these two objects are actually the same. Force 1 acting on 2 and force 2 acting on 1 is the same due to the Newton's third law. Action equals to negative reaction. So the formula is given by negative z times m1 times m2 over separation square. The z is a constant. This is negative 6.67 times 10 to the power of negative 11. Okay. The z doesn't have a negative sign. I missed out. The z is just a constant. It's just a positive 6.67 times 10 to the power of negative 11. If you look at the formula of a gravitational force, right, there's always a negative sign. There are two syllables there, IB and A level. For A level, it's always safe for you not to include the negative sign. For IB, I need to check. But if you need to include, then just include. Now, what is the definition of the negative sign? Why they need to put a negative sign? The negative sign, right, is indicating is an attractive force. So I write a statement, the red one, right? I say the force act in the opposite direction to the R. What does it mean? Imagine at first I have an object staying at the blue marking. Then I move this object to another blue marking at here. Then now I release the object. Where will the object go due to the gravitational force? Will it continue to go to right? No. Where will the object go? Left. Left, right? Yeah. So that's what I mean by the force always act in the opposite direction to R. So the force, right, acts out of the body of the object. The next one is we have gravitational field strength. Gravitational field strength is what you call as gravity at secondary. So now we don't use the term gravity anymore. We use the term gravitational field strength. So gravitational field strength is a gravitational force. Gravitational force divided by the mass of the object. So the gravitational force just now, you have the formula already, right? So let's say I want to find the gravitational field strength of Earth. So I have to take the gravitational force between Earth and I have to divide with the mass of the object. So at here, you can see the gravitational force formula is given by this, right? Then I divide with the mass of the object. So the mass of the object get cancelled. So the formula left is a negative g times m of Earth divided by x squared. So the gravitational field strength on Earth depends on the mass of the Earth because it cancels out with the mass of the object. You understand the derivation formula until here?
Sorry, what is x squared again?
X squared is the separations, the distance between these two pointed.
Oh.
So what is R, sir?
What is what?
R.
R is the, which R is that?
The force X in the opposite direction to R.
R is like the X.
Okay, sir.
Anyone have questions so far until here? No, you can take a picture of the board first, even though Vita will share it to you, but you can take a picture of it first. So you already learned two things, right? Gravitational force and gravitational field strength, right? Okay, finish taking already?
Yes, sir.
Okay. Now I will okay, you see another white screen already? No?
No, sir.
Not yet.
Not yet. Not yet, sir.
Yeah.
Yeah.
Um, what screen are you looking at? So the same screen we just now, or already a new screen?
New screen.
Already the first question is the moon has a mass of blah blah blah, is it?
Yeah.
Yes.
Okay, now we go with example first. As I give you the mass of the moon is this, and then it's located certain distance from Earth. And then let's say the mass of Earth is also given. Right? Calculate the gravitational force. Calculate the gravitational force between the Earth and the moon. So the formula is given by negative gm of Earth times the moon, right? Divided by the separation square. Separation means center of Earth to center of moon. So if you apply the formula, remember to change the x, yeah, to meter. So if you use kilometer, all of the calculation wrong already.
Okay.
So if you change it already, you get a gravitational force of 2 times 10 to the power 20 Newton. Later you can try to count. I give you time, you try to count. Next one, I ask you to assume the gravitational force is the same with the centripetal force of the moon. Calculate the period. The period of the moon. You know moon is revolving around the earth, right? So if I teach you last meeting, centripetal force formula is given by m times omega squared times x. So the centripetal force is you substitute with the gravitational force, right? 2 times 10 to the power 20. Then you try to count the omega. Later you got that answer. So this one is radian per second, yeah, the unit. And then omega, the formula is 2 pi over period. You substitute the omega, you find the period, you get that in second. You change to days. You remember at primary, from the dead moon to the full moon, I mean for that one cycle, yeah, it have to be 28 days, right? If you remember, the period of the moon revolving around the earth. Yeah, it's approximately 27 to 28 days. Now I'll give you time to calculate the gravitational force and the centripetal force first. In case if you cannot get the same, you can ask question, you can ask before I continue first. If you have questions, just ask. Yeah.
Yes, sir. So just now the omega squared formula, what is the formula, sir?
Omega is 2 pi over period.
Sir, do what, sir?
Now when you
I came
try
late.
to count first column and the second column, like you try to count first and tell me if you get the same answer or not. If you get the same answer, then I continue. I worry later if I discuss too far, no one understand.
So
Find
why
what,
you
sir? I came late, sir. I didn't hear.
You try to count the gravitational force that 2 times 10 to the power 20 and the period 22.26 days. Can you get that or not?
so why is the G negative?
Which G is negative? Oh, the G is not negative, just not typo. At the first word is a typo. The red color, right? Supposed to be positive 6.67.
So what's X, sir?
X is the separations.
Sir, I don't quite
So the period is
understand
how
the
many?
FG is not the same with the F-centric.
Wait, what about first? How? Which one, Mita?
The FG one, sir.
Okay.
I don't understand.
The Fg is the gravitational force between Earth and Moon. So the Z is a 6.67 times 10 to the power negative 11. And then we use mass of Earth and we use mass of Moon and divide with the separation square, which is the 3.85 times 10 to the power 5 kilometer. But must change to meter.
No, the yellow one, sir. The reaction force.
You mean the previous board?
This one, the key.
Oh no, that haven't. That is my explanation.
Okay.
So the first column and the second column, no one speak up, so I think done already. Everyone can get the same number.
Yes, sir.
So for the period, how long?
The period is 2.36 times 10 to the power 6 seconds. So if we change the second to days, it will be 27.26 days.
Okay.
So in primary lesson, right, we tell the primary students 28 days, right, for one cycle. Okay? Okay?
Okay.
Okay, now I continue. So the next question is, the next thing is gravitational force always the same as centripetal force? No. Gravitational force is not always the same as centripetal force. When you have a gravitational force the same as the centripetal force, we call that situation as weightless. So we have weight, right? I'm very happy if I don't have weight, but unfortunately cannot. So we have weight, okay? Because our gravitational force and our centripetal force is not the same. Later I'll let you prove it one more time again, but last time I tried to ask them to calculate already. So for all the revolving motions, the gravitational force and the centripetal force have to be the same. Why it need to be like that? If your gravitational force is greater than the centripetal force, it means by time the object will move to the center of the rotation. So imagine we are projecting a satellite, and the satellite revolves around the Earth. Right? So if the gravitational force is greater, it means by time the satellite will fall to the Earth. If the centripetal force is greater than the gravitational force, that also doesn't make sense. It means your satellite will leave the orbit. Imagine you swing a stone, right? Then you swing it too hard. What will happen to the string? Break. Will fly away. So for revolving motion, the gravitational force and the centripetal force have to be the same. So if they're not the same, then we have a reaction force, and that the reaction force is the one that we call as our weight. So we are going to prove that statement. Any question you want to ask until here?
So how you get F centripetal is mass of moon times omega squared times X?
Where does it come from, you mean?
Yeah.
First is a centripetal force formula, and then second, I think what is important from your question is when we have a Earth and Moon, right? Which one is revolving?
Moon.
Moon. So the only one that can have the centripetal force is the object that moves in a circular motion. So we never have a centripetal force of Earth in this case, except if you compare Sun and Earth. Which one has a centripetal force? Earth or the Sun have a centripetal force?
The Earth.
The Earth.
Earth, centripetal force. You can take a picture of this board and I will clear it. I will give you another calculations again to make you understand about the weight that I mean. Finish? Taking a picture?
Yes, sir.
Okay, so we are going to discuss the next one, yeah? About the reaction force is our weight. So now let's say, you know the mass of Earth just now, right? Mass of Earth. This one is given by 6.0 times 10 to the power 24 kilogram. Between the Earth and the human. Then you know the Earth is rotating, right? So if the Earth is rotating, means we have a centripetal force acting on our body. Right? Do you understand?
May repeat some.
Because the Earth is rotating, it means we have a centripetal force acting on our body.
Yeah.
And the period of rotation is 24 hours, right?
Yeah.
Yes, sir.
Then later you answer that 2 bullet. You can try to do already.
No,
You see the formula that you have, right? You can try to do. So later I see if you understand or not. We'll write down the answer also, okay? Just for you to check. Once you cannot get, you don't know what is going on, tell me directly.
Sir,
Yep,
I get 680.
83. Yeah, I round it off, see.
Oh,
No problem. No problem.
So I don't get the centripetal force.
So omega the same.
Omega the same.
Okay. What is the mass that you use when you count the centripetal force?
Is it the mass of the human?
Yes, mass of m omega square r, right? The formula.
M omega square R, yeah. The R use geometer or meter? Use meter.
Yeah, change to meter. Can you get ready?
Wait.
From
Oh, get ready, sir.
Okay. Anyone have questions?
So how to do the double ions?
The centripetal, do you get omega?
The omega, yes sir, I get, yeah, 7.3.
Then continue with the centripetal force formula. What is centripetal force formula that you use?
Which the formula is the omega square times r, sir. Wait, no, that's acceleration.
Yeah, omega squared times r times the mass of the object.
That's the yeah. That's to find the force actually.
Yeah, centripetal force. Which one you cannot get?
No, so just now I just start I get the omega already, but I don't know how to find this now. So the radius need to change to meter.
Mm-hmm.
so the centripetal force is omega square times r then times mass again enggak or not times mass anymore.
Can you get ready?
The answer is what, sir?
Sorry?
For the centripetal force. The answer.
2 point something just now, if I'm not mistaken.
2.3 I get.
Yeah.
So are you sharing your screen, sir?
Yeah, this one. But get clear all already.
Oh no.
Oh.
Okay, it's okay. But at least just now everyone can get ready. So I carry on, yeah?
Yes,
Yes,
sir.
Now I'm going to discuss about the orbital speed. So you understand that is a weight already, right? The reaction force is a weight, yeah? For the orbital speed, if you read the Lax formula, orbital speed is given by V equals to square root of G times M over X. So the M at here, the M is a center object. So let's say the moon is orbiting the Earth, right? So if I want to count the orbital speed of the moon, how fast the moon is moving, whose mass I supposed to use? Not the moon, but I have to use the mass of the sun, the mass of the Earth, right? But if you want to count the speed of the Earth revolving about the sun, whose mass that you have to use? The sun. Yeah. So we are going to discuss how is the derivation of the formula. Just now I told you earlier that the gravitational force and the centripetal force have to be the same, right, for orbital motions. So the gravitational force is given by z times mass of the Earth times the mass of the satellite. Moon is a natural satellite, right? Divided by x squared. So the one that have the centripetal force, I hope you understand already, it have to be the satellite. Because the satellite that move in a circular motion. The formula for centripetal force that I give you have two. So if I use the speed, it will be v squared over x. So the x been cancelled out. The satellite been cancelled out. So here, you need to have one understanding. Is the mass of the satellite that we are orbiting important? No. To have the speed, right? The mass of the satellite, heavy or heavy, is not important. That's how you get the speed equals to square root of z m of Earth, right? Over x. Do you understand that here?
Yes, sir.
And then v, on the other hand, is equals to omega x, right? So v just now you get ready, square root of what? Zm over x. I'm trying to show you how to derive the period directly. So if times I move become what? Divide, yeah. Divide means 1 over x, right? Understand it here? So if I write square root x squared, do you understand also? No answer means understand, yeah? So if I just extend the root, become like this. So I can combine them now. Over x to the power of what? 3, right? Equals that.
Sorry, sir, the 1 over x squared from where, sir?
It's actually 1 over x, but then add a square root. So after I root it, right, still get an x.
Oh.
So if I flip this, it will be 2 pi. Doesn't flip, right? Square root of what? X cubed over z me, right? Just now before this board, I asked you to calculate the period of the moon, right? How many days do you get? 27.26 days, right?
Yeah.
If you use this formula directly, then it's also with 27.26. Now for higher level, you have to know how to derive formula. Cannot only like memorize. If you only memorize, cannot, because some of the question will ask you to derive formula. That's the purpose of me explaining this. Any question?
No.
Sorry,
No question.
I have questions, sir.
Oh yeah? Go ahead.
I not understand the 2 pi over t become t over 2 pi.
I just flip. It's a fraction. So this numerator become denominator. So on both hands, I flip it.
Oh,
Any other question again?
So then is V equals to what times X? Omega.
Yes.
From where you get V equals to omega times x?
Last time in the first discussion, linear speed equals to angular velocity times x.
Oh, yeah.
Any other questions again?
So I don't understand from x become 1 over x squared.
It's actually times x. So if times x, you move become divide by x. Divide by x means times 1 over x, right?
Oh, okay.
I just add the roots so I can combine them together. Okay, now take a picture of the board and I will clear it.
So the x is r, right, sir?
Sorry?
The x is also r, right?
No, it's not always radius. You can use any symbol, but that have to be clear. It's the separation.
Oh, okay.
You try to count the speed of orbital for the moon first. So you can use this formula directly if you understand. The answer is around 1 million, not 1 million, around 1000 meters per second. In 1 second, it travels 1000 meters. Can you get 1000? For those can get, continue to these questions again. For those who can get, continue the next question.
So for just now, you got us the 1000 meter per second. What are we trying to calculate?
Speed of orbital of moon.
So the x is separation between Earth and Moon.
Yeah, the 3.8 times 10 to the power 5 kilometer. Yang first board, I think.
And so the G and ME is mass of Earth, and G is the gravitational force between Earth and Moon.
No, the Z, that capital Z is gravitational force constant. The 6.67 times 10 to the power negative 11.
Oh, okay.
Sir, the G, you need to always memorize it, sir. The 6.67 times 10 power by negative 11.
The G without the negative, just 6.67 times 10 to the power negative 11 only.
Oh, you always have to memorize that, yes, sir.
No, it's given in the booklet. If you take A-level or IB exam.
Oh, okay.
Sir,
Yeah.
for the new question, The mass of the Earth the same.
Same. Same. The Earth is not taking diet. I want to tell you the answer for these questions already. Everyone already have answer?
Not yet, sir.
Okay.
Not yet, sir.
Okay, okay.
So this one 2R is 6,402 lah. Then convert to meter.
Sorry?
For this one, this question, the new one, say that the satellite is orbiting at a distance of 2R above the
Above the
Earth's
Earth's surface. Yeah.
So it's the X 6,400 times 2.
I want you to think.
So then the 2R is center to center already, no, sir?
No, you read the question carefully.
Earth's surface. Okay.
So the distance 2r is above the Earth's surface, right? Not just center from center. If from center to center, how much is the x supposed to be?
3R.
3r, yeah?
Same.
So when separation is always to the center of the object, also.
Yeah. Yeah.
Sir.
Yep.
Why is it 3R? Why not 2R, sir?
Because must be center to center.
Also add another, so add R again.
Yeah, this one is usually become problem with the exam. So usually the students can do it.
Oh.
Sir, how do we get the 3R, sir?
Sorry?
How do we get the 3R, sir?
Because have to be center to center.
Like, is it given or we find 3R by ourselves?
The question say it orbit above 2R, right? So if you add with another R of the Earth, then it will be 3R from the center to center.
Okay.
Anyone still doing? If we continue. So there are two types of satellite. So green done already? Or anyone still doing?
Already okay, sir.
Okay, so no other statement, I continue, yeah? So there are two types of satellite. The first one is geostationary satellite. When someone says geostationary satellite, it means the period, the orbital period of the satellite must be equal to the period of the planet to rotate above its axis. So, for example, I say geostationary satellite of Earth. I use this statement. I say there is a satellite, and I call the geostationary satellite and I call this satellite as geostationary satellite of Earth. So, what is the period of Earth to rotate about its axis? 24 hours. So, means the satellite, the period of the satellite, also have to be 24 hours.
Okay.
So it is 24 hours because it is the geostationary satellite of the Earth. So the period depends on the planet that he is orbiting. Do you have any questions until here?
No, sir.
And then another characteristic of geostationary satellite is for Earth here. For Earth is located above the equator line. Then the period, as you know already, equals to 24 hours. And it moves from west to east. East to west. And it appears to be at a fixed point. Because it revolves the Earth with a period of 24 hours, does it appear to be moving?
No.
No.
No, it appears to be not moving. That is the first type of satellite. Then another satellite is known as polar satellite. Polar satellite move in a polar, move around the pole of the Earth. Polar satellite has a shorter time delay, but then it needs to be tracked because the position is not the same. What do I mean by shorter time delay? If you ever learn about the geography lesson, Earth is slightly dented, right? So which one is a greater size, the orbit? And the equator will be greater, right? Compared to the polar.
Mm-hmm.
So which one take a shorter time?
Pole.
The polar. And then second, you see this part is quite dented. It looks like orange, so it's quite dented. So your satellite, like the track, the path taken, right, can be closer to the Earth. At the equator orbit, right, the things is quite wide. It's getting wider. So means your satellite need to be located further. So if you take the polar orbit, your satellite can go closer to Earth. So means to reflect the signal, does it take a longer time? If your satellite can go closer to the Earth, will it take a longer time to reflect the signal back?
No.
No. That is the advantage of using a polar satellite. But then the disadvantage is you have to track it. So the position is not the same with the geostationary satellite, which appear to be at a fixed position. So if you want to use the satellite for the spying purposes, right, you have to be polar satellite.
Okay.
If you want to use it for spying purposes, it's only the polar satellite. Understand? The geostationary satellite cannot be used for spying. Because the geostationary satellite, right, could be tracked easily. A polar satellite is difficult to track. But then for communication, for normal communication, no one uses polar satellite here. People just use geostationary satellite. Any question? You can take which off the board. I stop until here. After this, I will give you practice. So those who are not clear or what, you can practice again. Okay?
Betul.
Okay, sir.